Go.
Good morning, ladies and gentlemen. Let's talk about spring scales and springs today. So here we have spring scales. And
What?
it is a spring with a scale on it.
Oh yeah, spring scale.
And the scale is in newtons. Okay. So it takes a force to stretch our spring, and as you can see, take a lot of strength to force to stretch that one. And then we've got this one right here. Okay, I can definitely stretch it a little bit further with the same amount of force. And then with, whoa, this one is really easy to stretch.
Oh, why don't you?
Okay, so here I have my 500 gram mass. Okay, and check that out. So when I let go of it, it doesn't move very much, right?
That's right.
Okay, it moves only like 5 newtons. Can you see that?
Yep. 5
Okay.
newtons, 500 grams, 5 newtons. That makes sense.
And check out the thickness of that spring.
That's a big boy.
Yeah, now compare it to this one, right? This one's a lot more skimpier, okay? And then I'm gonna go ahead and put this on here. Wow, it went a lot further.
Stretches a lot more, but what does it say?
About 5 newtons. Wait,
5 newtons?
5 newtons, yeah, okay. All right, okay. And then this is our last guy right here, and you can see that spring is even scrawnier.
Yeah.
Okay, so here we go, try to lift this one up, and
Whoa, goes all the way to the bottom, but what does it measure as?
5 newtons.
5 newtons. So it's the
Okay.
same weight, the same force pulling down, but you get different stretches out of the springs.
Yeah, and why is that? Well, the strength of the spring is different in each.
Yeah.
And that's something that we can.
We need to figure out some stuff about springs.
Okay, so the first thing is that these are just some definitions. It's just stress, and stress is just the force applied to a spring. So when I put that mass on the spring, it applies a stress to it, right?
Yeah.
And the strain is just a change of length. So you apply a force, and it changes the length.
Yeah.
Okay. These are not as important as these. These are the most important.
Yeah.
So equilibrium is the unstrained position.
Yeah.
And the restoring force is the force that seeks to return it back to equilibrium.
Yep.
So when you pull on that spring, you're applying a stress to it, and you're getting it out of equilibrium. But the whole time, the restoring force is trying to pull it back into equilibrium.
Yeah,
back to where it's
the spring just wants to be chilling. It don't want to
Yeah.
be all stretched and strained.
to hang out.
That's right.
Okay, Hooke's law. The restoring force of a spring is proportional to its displacement from equilibrium, ideally.
Yeah.
So-
The farther you stretch it, the stronger the force that it puts out.
Kind of like a rubber band, right?
A lot like a rubber band.
Okay. So when you are, if you had that good demonstration, Mr. Boykin. Okay, if the force is being pulled in this direction.
You're pulling it to the right. What direction is the spring pulling?
Okay, we'll call this the positive direction.
Yeah.
The spring is pulling in the negative direction, the opposite direction.
That's what that negative is for.
Mm-hmm.
Whatever the displacement is, the force is going to be in the opposite direction, trying to restore equilibrium.
So here we have our constant, our spring constant K, where K is the spring constant for that spring.
It depends on the nature of the spring. You got
Yeah.
a thick spring, it's going to have a stronger force for the same displacement. Weaker spring, a weaker force for the same displacement.
And you guys saw the different spring sizes and how they went more distance, right?
Yeah.
With the same force. So here is our equation for Hooke's law put into equation form. It is simply the force of the spring equals the spring constant times the displacement.
Yes.
Okay.
Yep.
Find the spring constant K for each spring scale.
That's these guys over here. Well, what do we need to find the spring constant? We need the force. Let's see, what was that? No.
There it is.
There you go.
Okay,
So we need to find the force of the spring and divide that by how far it stretches. There's a number of ways to do it, but there's an easy way to do it.
Okay, so the easy way, let me go over here. So this is my weakest spring, okay, and it has the capacity to hold 5 newtons. Let's go ahead and just measure out
So it's like a ruler on the side of the sink.
Yeah.
So that's about 5 centimeters.
Yeah, it's about 5 centimeters. So 5 divided by 5 is 1.
5 centimeters divided by 5 newtons divided by 5 centimeters.
So 5 newtons divided by 5. Oh, should we be using?
No, go ahead and
meters
use centimeters. It's okay.
Okay, so that gives us 1. And what are our units for this?
What's on the top divided by what's on the bottom?
Centimeters.
Yep.
Okay, so that's our green one. Okay, and then let's go ahead and find the one for this one. Okay, so we have okay, so this one's at a 10 newtons. I get 5. Look at that.
5 centimeters.
For 10 newtons.
10 newtons.
Divided by 5 centimeters. So we get that's 2.
2 newtons per centimeter. So that's a stronger spring.
Okay.
What about this thick yellow one?
This bad boy over here. Okay, so up to 50 here. That's interesting. This one. Okay, and yet again 5. Woo. So 50 newtons divided by 5 centimeters, and that's 10, right?
10 newtons per centimeter.
Okay, so what does this tell us? Well, these are the spring constants. This was my brown. This is for the yellow one. This tells me that my spring here, this thick spring, has the largest spring constant.
Yeah.
Okay, and that means that it's going to take me more force to pull it the same amount of distance.
Yep. Now, something occurs to me. Well, on the green one, the weak, wimpy guy there,
this guy?
if you stretched it out 2 centimeters, how many newtons would you expect to get?
Oh, 2 newtons.
Yeah.
Right.
If you stretched the brown one out 2 centimeters, how much would you expect to get?
4 newtons.
That's because it's 2 newtons per centimeter. So for every centimeter, you get 2 newtons. And for this one, you stretch it out 2 centimeters, you're going to get?
20 newtons.
It's a simple thing.
Woohoo! Okay. So that's that. I think we're ready to send them off on their way.
Let's just
Oh, sorry. Right
do
here.
a few problems out of the book right here, right now in class.
So go to page 274, and you're gonna do numbers 1, 2, and 5.
Simple.